Collections. Hello everyone, this is Ben Finkel, and in this nugget we're going to take a look at how to work with collections of data inside of the Python programming language. We'll kick off this nugget by talking about what exactly collections are in the context of Python. Specifically, they are lists and dictionaries which allow you to have multiple different values stored in a single variable so that you can work with them collectively. Lastly, we're going to finish up by taking a whole bunch of code, and we're going to look at how we can add, remove, and change items in these collections, both in lists and dictionaries, and see how that makes life a lot easier for us as programmers. There's a lot to cover in this nugget, so let's get started. Variables inside of Python, or really any programming language, are pretty useful little guys. They allow you to store a value for use throughout the rest of your program. So you can say, x equals 16 and store the value 16 inside of that variable x. You can say y equals Ben. You can give it a name, a string, and you can create a string value in memory and reference it using that variable name. Well, one thing that we haven't talked too much about is the fact that each of these variables, x or y, or if you say z equals 4.7, each of those variables has a type associated with it. And that type in Python is created dynamically the first time you assign a value to the variable. So when I say x equals 16, what's happening here is x becomes an integer type variable. When I say y equals Ben, it becomes a string type variable. This became a float type variable. Those are built-in basic data types, they're called, in the Python programming language. And it's important to know what the data type of your variable is, because once you assign data to a variable and it has a type, you can't change its type. Once I've said y equals Ben, and I used the quotes to indicate that it was a character string, then y forevermore is a string. I can't turn around and assign a float value to it and then treat it like a mathematical variable. It's a string variable. That's the type of data that it's going to store, that it's going to point to. So what does all this have to do with collections? Well, collections are another type of built-in data type inside of Python. And most programming languages have collections of some kind. So not only do you have your basic scalar single value data types, your integers, your floats, your strings, your booleans, whatever, you've also got some kind of collections, arrays or lists or iterable objects, whatever they're called. And Python has two specific collections that we really want to talk about. We're going to talk about lists, which also includes the subtype tuples, and dictionaries. So these are pretty simple to get our heads around once we understand what variables are and how they store data. So let's get started talking about that. In Python, lists are exactly what they sound like. They are simply a list of values that is stored in memory alongside of an index. So they're very easy to define. You simply define your variable name, say x in this case, an equal sign, your assignment operator, and then the values. You use a square bracket and you separate your values with commas. So here I've indicated that the values of the x list should be 1, 2, 3, and 5. And the way to think about this is to imagine that a table is built in the background inside of memory. Let's call it the x table, and it's going to be a combination of indexes and values. The indexes start at 0, and the values are whatever I defined the values to be. So this table in the background says that at index 0, we have a value of 1. At index 1, we have a value of 2. And you can always reference these simply by using the syntax variable name bracket index. So x2 is going to return a value of 3 because I used 2 for the index. The value stored in that position in my list is the value 3. Tuples, for what it's worth, are exactly the same, except they are what's called immutable, and you define them using a parenthesis instead of a square bracket. So if I go 1, 2, 3, 5, now I've created a tuple. It looks exactly the same, and I work with it exactly the same, except a tuple is what we call immutable. That means it cannot change. It is fixed with that list of those exact values for the entire lifespan of my program. A tuple doesn't come up too often, but it might be used to store something like a list of months, let's say. You know what? There's 12 months in a year. We know what they're going to be. They're never going to change. You can store a list of months inside a tuple, whereas values that might be dynamic or flexible that the user might add to or change, those you're going to want to store inside of the basic list. Couple of points about lists. You can add to and remove items from lists. You can also change items in lists. And lastly, lists do not have to have all of their items be the same basic type. So the example I used here, 1, 2, 3, 5, I made all of them integers. Well, you could also say something like x equals 1, 2.7, Joe, and so on and so forth. You get the idea. So every item in the list could actually be of a different basic built-in type inside of Python. The list is simply the collection, the container object that creates this table of each of these individual items. In fact, because lists can contain any of the basic built-in data types, they can also contain other lists. You can nest lists inside of each other with the simple syntax x equals bracket 1, 2, bracket 3, 4, bracket, bracket. So here I've got a second list inside of my first list in position number 2. So x2 is actually equal to 3, 4, in case you were wondering. So something to keep in mind, you can use lists in a lot of different ways, and they're really, really powerful that way. Now dictionaries, on the other hand, and I've taken up most of my space here on my slide, dictionaries allow you to customize the index yourself. A dictionary is Python's version of a key value pair. And what that means is, just like we had an index and value over here on the lists, on a dictionary we're going to have a key and a value, only the key doesn't have to be a sequential list of numbers that are assigned by the computer. The key is anything that you want it to be, defined by us as the programmers. The basic declaration for a dictionary looks like this. We say variable name equals curly brace, and then we go with key, let's say that, colon, value, comma, second key, colon, value, and close it with a curly brace when we're all done. So this creates here a table of our keys and our values. And here my keys are Jack and Ben, and my values are 1, 2, 3, and 3, 4, 5. So I can reference any of them the same way I referenced my list items. I can say x Ben, and that's going to return the value 3, 4, 5 because I looked up the index Ben. So lists and dictionaries are very similar kind of things. The difference is dictionaries allow you to define that key yourself. There is no index on a dictionary, whereas lists have a index that's defined sequential numerically starting with 0 by Python itself. Now that's enough scribbling. Let's take a look at the code and see exactly how this works inside of our Python environment. Let's start with the command line interpreter and just see exactly how Python lets us work with these list values very, very easily. So here I am at the command line, and just like I could say x equals 3 and then print x, and I get the value 3 out, I could say x equals 1, 2, 3, 4, 5. I've defined x as a list here. Notice I've got the square brackets on the outside, and then I've got my comma separated list of values. So now when I print x, you can see I get 1, 2, 3, 4, 5 with the commas and the square brackets. So Python spits out the value exactly the way that I input it. If I print x, let's say 4, you can see that gets the value of 5 because the fourth index is the value 5. And it's important to remember that they are indexed starting with 0. So it's 0, 1, 2, 3, 4. If I tried to reference the index 5, that doesn't exist, and I'm going to get an error when I do so. Specifically, the error that I'm going to get is index out of range, which is stop and think for a minute. That actually makes sense. The index that I supplied, 5, is not inside the range of valid indexes, which are between 0 and 4. So it's real nice. The tuples work the same way. If I go 1, 2, 3, you can see that I can print x. And now it shows me 1, 2, 3 with the parens instead of the square brackets because it's a tuple. That's how I defined it. And same thing with dictionaries. If I say this dictionary equals Ben 1 and Jack 2, and then I print x, you can see I get Ben 1, Jack 2. And again, I can reference the dictionary items just with the brackets here. So I'll say Ben, and there I get 1 because the value of the dictionary at index Ben is the value of 1. Now it's important to note here that dictionaries do not have an order to them. So when I define my list or my tuples, the order that I define them in inside of the list is the order that they were stored, that they were indexed inside of that table. But if I come here and let's say I do something like this. Here I've defined 3 elements inside of my dictionary, Ben, Jack, and 99. Notice, just like a list, I don't have to have the same data type for my indexes. I can have both strings and numeric values as indexes in my dictionary. When I assign this, if I print this out, and I think this will happen what I want it to do, notice that 99 showed up in front, and then it's Ben, and then it's Jack. So you can't really rely on the order of things inside of dictionaries. They don't have positions, they don't have an order. They are this nebulous collection of key value pairs, the key and the value together as a pair. Let's take a look at some of this in action now in a broader Python program. Here we are. First things first, I've defined my variable names, and it's a list of 5 different names: Ben, Sally, Amy, George, and Randy. And here I'm just printing each of them out by their index. So square bracket, then the index numbers 0 through 4. Remember, that's how they're indexed. And we can see this run here. I'm just going to type Python list1.py. And there it is: Ben, Sally, Amy, George, Randy. No problem. Makes a lot of sense. But why even put them inside of a list to begin with? I mean, why not just create 5 different name variables and use them however we like? Well, for one thing, lists can be used inside of for loops. Let's take a look at that. Here, I've shortened up that code dramatically. Notice that now, instead of having to print each individual item from the list by index, which, is hard-coded, if I wanted to add another item to that index, I'd have to go and change my code. Now I've got a for loop, which is just going to loop through every item inside of that list. So I've created a variable called name. Notice it's different than names. It doesn't have the S on it, so it's a totally different variable. I could call it X or Q or P or whatever, but one nice standard is to call it the singular version of the plural that you're using for your collection name. So for name in names, I'm going to print name. So this loop is going to go through, it's going to iterate through each item on this list, and it's going to print out the value of each one of those items. And I can see that in action here. Does the exact same thing. It's just way simpler. It's much more dynamic. It's much more flexible. If I decide to add a name onto this list, I'll just come up here and I'll say Alice is now on my list as well. Save that. All I have to do is rerun, and now Alice gets printed out along with all the others. So I didn't have to go and add another print statement. The list was able to be programmatically sorted through and printed out. Now, a lot of times you're going to want to work with the indexes from your list anyways, even if you're inside of this for loop, which is ignoring the index and taking that out of hand. You're either going to want to know what the index of the item is, or you're going to want to iterate through those indexes. There's a couple of clever things that you can do to work with lists and get that information out. So take a look at the first one here. I'm going to use a function called len, L-E-N, and that's short for length. And what that does is takes a variable, either a string or a collection, or even a number, and it returns the length of that variable. In the case of a list, the length is going to be the number of individual items in that list. So I can print the result of that function call. So I'm storing the result inside my variable x, and then I'm printing x before I print the list of names. And I'll come here and I'll say execute my code. And you see it prints out the list of names, but on top of that, before it printed the list of names, it told me 6. There were 6 items inside of that list. So how can I use that? Well, we can combine that with the range function like so. Here I've got my length function inside of my range function, all as a part of the for statement, and that allows me to use both the index as well as get the name out of my list inside of my print statement here. I'm going to execute it and then I'll talk about exactly what's going on. So come over here, say Python lists2, and you can see Ben is found at index 0, Sally is found at index 1, etc., right on down the line. So what I've done here is I've used the range function to create a totally new list of numbers that my for loop is looping through. It's no longer looping through names, it's now looping through a range of 0 to, well, 6. If If I had just put 6 in there, it would have been 0, 1, 2, 3, 4, 5, right? That's how the range function works. And I'm calling that, I'm storing that inside of my index variable. So every time I loop through, my index goes 0, then 1, then 2, then 3. So I can simply reference the item inside of my array with that variable, names bracket index. So I get a hold of both my index and my name. Now I mentioned that there was another way to get the index out, and that's with something called the index function. And this is a part of the list. Let me show you how this works. What I've done here is taken advantage of a function that exists on top of lists inside of Python. And we'll talk about complex objects in a different nugget. But just know that some objects or some data types have additional functions that you can call, like I've done here. I've called names.index. And that index function takes one parameter, and that's a value, and it's going to return the index of that value, or at least the first instance of that value. So what this should do here is this should look up and find George and give me the index of 0, 1, 2, 3, I think, right? It's the third index. So let's take a look and see that code run here. I'll make sure it's saved. Execute. And yes, you can see before it printed out, I got an indicator that the index of George was 3. So I can use that right down in my for loop if I want to do something like this. Here I've got names.index open paren name right down here inside of my second for loop. And what that means is that on each item, it's going to look up the index of the particular item that I happen to be looping through at that time. So I'll go ahead and save this and just validate that it works the way we expect it to. And there you can see it did it twice. It printed out the first time using the len inside of the range function, and then the second time using the index function that's a part of the names list. Now there's a few other functions we should look at on lists as well. Here I'm doing a couple of functions that you can perform against lists inside of Python. Notice for starters, I collect a new index and a new name from the user, and then I update that index with the name that the user keyed in. I simply do that by using the bracket notation to reference that particular item in the index, and the assignment operator, the equal sign, to put that value, that name, into that position of the names list. And I print it out when we're done so that we can see that it's been changed. So if I key in 3 as the index and I key in a new name, it's going to replace George, which is the third index item on this list. Below that, I call 2 new functions, append and remove. And those are functions on the list type of variable itself. Any variable that you define that's a list, you can call these functions against. And you call it with the variable name dot syntax. So names dot append is going to append whatever parameter I put inside the parentheses onto the list. Names dot remove is going to remove whatever name I put inside the parentheses from the list. And we can see it all in action down here. We'll say Python list3.py, and the first thing it does, it prints out the list, and then it asks me the index that I want to replace. I'm going to replace 4, and the name I'm going to put in is going to be Joe. So now it prints out, and you can see that index number 4, which was Randy, got replaced with Joe because I updated it. Now it says, what name do I want to add to the list? Well, I will add Eric onto the list. And now it prints out, and you can see the append item, just like it sounds like, appended that value onto the end of the list. My list is now 1 longer than it used to be. And I can also remove a name from the list. I'd like to remove Ben from the list. There we go. One more time. It prints out the list, and you can see that it's now shortened by 1. Ben is no longer a part of that list. So lists can always be updated, appended, removed, etc. Lists are mutable. If I had created this as a tuple with the parens instead of the square brackets, none of these functions, none of these things would have worked. Tuples are immutable. They cannot be changed. I would have gotten an error the very first time I tried to do one of these things. Now dictionaries, for their part, work more or less the same as lists. Only remember, we don't have that automatically assigned numeric index anymore. We have a key that we assign ourselves. So here I've got my dictionary defined. It's a list of ages, and my keys are the strings that are on the left-hand side of each of those colons. And then the value is on the right-hand side of those colons. So Ben 35, Joe 37, Sally 22. So this is a dictionary of people and their ages, at least how I'm imagining it. And we can use it, we can print it out in a for loop just like we could with the list. We'll see it in action here. And there it goes. First it prints out, you can see just like the list, it prints out in the exact same syntax that you define it in. So I got my curly braces to define that it's a dictionary, and my colons, my quotes, my commas, just like that. But notice when I printed out my age in ages from my for loop, all I got were my keys. I didn't get my values. So dictionaries have to be worked with slightly differently than lists when we want to iterate through them. For a dictionary, I've always got to reference the value using the brackets from my key. So when I did the for age in ages, I got an iteration of my keys inside of my dictionary. So then I can use that key to simply reference the exact value, the exact position inside of my dictionary that I want to get the value out for. And remember again, the reason for this is that dictionaries don't have an order. You can't loop through a dictionary that doesn't have an order. It's just this big bag full of key value pairs. So we're going through the keys, we're looping through the keys, and we're getting each value out using this syntax. It should work just fine if I give it a run here. And there it is. The age of Sally is 22, the age of Ben is 35, etc. So it looped through, it got my age out of my dictionary using the bracket notation to reference the individual element inside of the dictionary. Dictionaries have one cool function known as the keys function. If I say print ages dot keys, I don't have to pass anything into the keys function. The keys function is simply going to return a list of my keys, and I use that word list very specifically. If I go ahead and save this, run my code one more time, you can see that what comes out on top is Sally, Ben, Joe, Jeff. That's my keys that I would expect. But notice that they're in bracket notation with the comma separating them. That's a key to us. That's a hint. That's a clue that keys, the function, is returning a value, and the value that it's returning is of a type list. So I could actually do something like this, getting crazy, but you may need to do something like this. I can say x equals ages dot keys, and then I can print x2. So that's going to tell me the second key that was returned from my keys list, right? Because since keys returns a list, it's putting the list back into x. Then I can reference it by its ordinal position. Let's check it out in action. Look at that, Joe. So it picked up the second index, which was Joe. Now what dictionaries do not have, separate from lists, is they don't have the append and the remove functions on their objects the way you did with a list. You do that a little bit differently with dictionaries. Let me show you how. So here I've got a program similar to the lists program that I did earlier in the nugget, and all I'm doing is asking the user to change one key here and then add a new value here and remove one here. And notice I don't have the cool .append and .remove functions. In fact, what I have is I simply reference the value that I want to update or add. These two work exactly the same. You can see here I just reference ages with the new key and I assign the value. If that key already exists in the dictionary, it's going to update my value. If that key does not already exist in my dictionary, it's going to create a new value. As far as removing goes, I'm going to use this keyword del. You can see that right here. And I'm just going to delete the value from ages with the key that is supplied. So let's see all of this in action right now. Come in here and just execute my program, dictionary2.py. And the first thing it does is it prints off my dictionary, Sally, Ben, Joe, and Jeff. Please enter the key to change. I'm going to change Ben. I'm going to make myself 22 years old. So there you go. Now you see that the dictionary has been updated. Ben has been set equal to 22. Now it wants a key to add. So I'm going to add, let's do Joe. Nope, Joe's already on there. Let's add Alex. And we'll make Alex 99 years old. And you can see, there we go. It added an Alex with a value of 99. Now it wants me to enter a key to remove. So let's remove Jeff out of here. He's 18. Hit enter, and there you see it prints it one more time with Jeff having been removed. So same as lists, dictionaries can have items appended to, added, removed, etc. The syntax, the code is just a little bit differently because you need to define the keys yourself. All right, that concludes this nugget on collections inside of the Python programming language. Just to recap, we took a look at what collections are. We talked about the fact that they are built-in data types inside of Python, lists, tuples, and dictionaries, that similar to integers, floats, etc., are built right into the Python library itself, but the difference being they don't just store an individual value, they store a list or a collection of values, and you can work with them collectively. We talked about the two different main types, lists and dictionaries. Lists being a collection of items that get a programmatically assigned index, while dictionaries get an index that's assigned by us, the developer. And then lastly, we wrote some code. We saw how to iterate through lists and dictionaries using a for loop, and we talked about adding, removing, and changing the items in both of these types of collections. I hope this has been informative for you, and I'd like to thank you for viewing.